Thank you for that introduction. First, clarification. I'm not a doctor, but I sit on the intersection, which is medicine and engineering. So very often people refer to me as a doctor. Thanks, but no thanks. So I think on the topic of enriching life through science, we have committed ourselves to innovations by design. That means it's rare that innovations happen by serendipity or by accident, but if we design for it, more often than not, we will come up with innovations which matter. Innovations need not be at a global scale. Innovation can also be at a very small level. But if you design for it and develop that, innovations can happen. And we as a company at Accreate Labs, we are research-led, but specifically application research. We are not big enough to do fundamental research, but we saw phenomenal opportunity to do applied research in very niche or specialized verticals, which is what we chose, which was aerospace defense on one side and healthcare or life sciences on the other side. And secondly, being engineers, we look at everything as systems engineering led, because from a concept to a design to building it, testing it and delivering it, it's a whole system engineering chain. And that's the value chain which we want to lead and thrive in. And lastly, if we don't create innovations, then we are probably wrong. And we decided that innovations will start with our own products as well as client-related work. So that's why I would say that we are very much innovation-centric, and we'll spend the next few minutes looking at what we are doing and how we are doing. And maybe one last qualification. There's so much to inspire globally in terms of innovation. And one of the key things, given our consulting background, we thought about was, why not bring global leading practices in life sciences and in aerospace to the user community in India and help them adopt that, accelerate its adoption. So in a way, you can say that we are researching, bringing globally relevant practices and helping clients adopt them much quicker. Okay, so we'll talk about life as it is today, and knowing that how could we further enrich life, and what's the role of science, what are the intersection points which we think we at Accreate could enable, and lastly, what do customers really want? I think that's important as well, and looking at some innovations and inspirations. And lastly, what are the success we are seeking and how far have we been able to go down that route? So I think when we look at life, lifespan has definitely increased with time, but still 65 years and more is seen as a maintenance age. Definitely people need maintenance, and when affordability and economic power increases, everyone wants a better quality of life even beyond 65. So there's a need there. Secondly, if you look at quality of life, I think reasonably comfortable. And there is, of course, work-related stress. We are economically well off, but that brings work-related stress. So that's something we have inherited now. And of course, there are great moments in life, which again encourage you to look for more of that. And health, it's mostly well managed. There are exceptions for sure. And however, lifestyle-related aspects bring in disease and healthcare-related challenges. And some of that could be very threatening. When you look at security, disruptions are more common, breakdowns, cross-border threats, and so on. So it's not that everything is rosy. There are some challenges which are still to be solved as well. Product development. I'm not necessarily talking of software. I'm talking of product development in general. It's slow. I'm saying when you do something small, it's quick. But the moment you're working globally dispersed teams, the product assurance requirements make it cumbersome and slow. So maybe that's also one of the characteristics today. And it's changing, no doubt in that, to digital, network, and collaborative. So let's see how we could enrich life. Now, when it comes to lifespan, you could live up to 100. But problem is, what if you have disability? How will you manage disability? This is an area where we think enrichment is possible. Next, when you look at senior management approach, seniors today may or may not get personalized and individual attention, but there is a need for managed healthcare for seniors. And lastly, orthotics for every individual who needs it. Today, orthotics and orthopedics are sometimes seen as a t-shirt, small, medium, large, or what's the nearest fit. But our idea of orthotics is personalized for every affected user. Now, to do that, naturally, design plays a very important role, but that's one way of enriching that. Then if you look at quality of life, personalization. There's a Forbes 2018 report which talks of personalization as the #2 driver to make additive manufacturing far more widespread. So in every aspect of life, we want personalization. That could mean healthcare as well. So personalization is going to be a big thing. And social, people do much more work socially. For example, telemedicine. A lot of things are now going to ride the virtual world. So this also needs to be the fabric of the architecture of things we make. Lastly, drug transportation studies on human tissue. Now, many of us know that regulations have impacted the way you can do studies on animals when you are discovering drugs. Having impacted the industry, is there a better alternative? For sure there is. How about if you did your test on human tissue rather than on an animal, have a much lower success rate and then get on to the commercial production. So today it's possible for drug transportation studies to be done on human tissues. This is enriching life. Can we run video 1, please?
The black area is the tumor. The white area are the ribs surrounding the tumor.
Michael Slag is in awe of a tumor. Well, a 3D printed model of the tumor that was growing at the top of his right lung. A Mayo Clinic surgeon removed it in a minimally invasive operation, and just 3 days later, he's going home.
Well, it's unbelievable. In fact, I was walking the first night after surgery.
Unbelievable because of how this 3D model spared him from what surely would have been a much more invasive operation with a far longer and more painful recovery.
But I'm sure if my chest would have been split open, I probably would have been in an ICU and probably a whole lot different experience.
This tumor, it's sitting right by the brachial plexus.
The growth was a type of lung cancer called a Pancoast tumor, so rare that Mayo Clinic has only seen 60 cases in the past 20 years.
We frequently may have a plastic surgeon, an orthopedic surgeon, a vascular surgeon, and myself all involved in a Pancoast tumor research.
Complex set of nerves that run the arm, knowing that I was more likely to come out with a hand that worked compared to an arm that wasn't going to do very much was just a big load off my mind.
For the Mayo Clinic News Network, I'm Dennis Doty.
The thing to see is, this is an example of a leading practice from Mayo Clinic. The two things which one could recall from there is, one is, it's a very sensitive area where if there's an error in the procedure, it could hurt his ability to do a surgery by causing paralysis and problems in his hand. That's number one. Number two, I had an opportunity to talk to a leading oncology surgeon who refused to believe that a laparoscopic procedure on a Pancoast tumor was possible. This is where the gap and ability to fill the gap exists. That means these leading global practices, when supported with technology, supported with services, and helping people derive outcomes which they can depend on. This is the opportunity we see in life sciences, where we could help doctors do surgery much more easily and much more effectively. The role of science. Many times, being an engineer, it's hard to understand doctors, it's hard to relate to them or bring technology into their everyday life, because they're dealing with life and they need that assurance that here is someone who understands life sciences and can bring technology which will not compromise a patient's life safety. So translational research is an emerging area where engineering can really share equal space with medicine. Translational research essentially is the stage after a lab research, where you're now doing bedside research with a or a couple of selected patients and actually working on the patient through these innovations. And that is where this intersection, which also fits in very well into another concept called bioprinting. Bioprinting is what I would introduce as the next frontier in 3D printing. where you're essentially printing with living cells on a predefined geometry for a specific patient's requirement. That means living cells forming skin or cartilage or bones or other simple tissues. So that's the next frontier in 3D printing, and regenerative medicine and bioprinting really extend translational research capability in producing results and strengthening the next stage, which is public-based mass drug introduction programs. Within regenerative programs, I was quite inspired with the Stanford School of Medicine's newsletter, which talks of new pathways to discovery. Traditionally, there has been a very set way in which discovery is done. But now, more and more reputed institutions are broad-basing this and building research teams which are cross-discipline, cross-dimensional. And this is where we think that there is a phenomenal opportunity of accelerating drug discovery, patient research, and ultimately enhancing the quality of life. Now, if you look at new pathways, some examples which I thought were relevant were one is tissue engineering. No one imagined 2 years back that you could 3D print tissues. Two-dimensional cell culture, tissue culture was always in practice. But the fact that you could build a 3-dimensional tissue and use it for research, for establishing the efficacy of a hypothesis is now a reality. Today, commercial bioprinters are available, and people who provide services on that and help you further your research is also common. That's an area where we are into. And organ bioprinting. Today, people would say that tissues is the edge of what you could bioprint, but the next thing would be printing organs. It is possible that organs would get printed. What makes it a long cycle is, even when you are bioprinting an organ, you have about 7 to 10 years of approvals. Then you get into limited trials. The whole process is long, but if you don't start with lab research, you'll anyway not get there. So the idea is everyone should take their areas of interest, start with research, and try and get on their path where they can accelerate and reach the end a little faster. This is where we see organ bioprinting becoming a reality. Just to mention, bladder, human bladder was the first organ to be bioprinted and even has been implanted. And now they're getting into the next stage of research where more and more patients will be tried and it would be expanded. So bioprinting gives a chance where you could probably get into more organ printings and relieve patients who are suffering from dysfunctional organs. Just to mention another area, but microfluidics. Again, no one imagined that 3D printing could move from synthetic to living material. But with that happening, cartilage-related research, which was lagging behind in terms of the innovative things you could do, has now taken a boost with the ability to bioprint microfluidics along with tissues. So that's another area which has shown a lot of promise. And also to mention that two neural cells have been bioprinted directly on scaffolds to produce a new neuron. This again is an example of how you could use this as a platform to conduct your research. So that means research can be today a little lesser of lab research and a little longer period of translational research, so that in the end the overall cycle time is lesser. This is the promise which this technology provides. And to give other examples, things that have already been bioprinted: liver tissues, cardiac tissues, skin and bone. And they have produced phenomenal promise. And for example, there are examples of valves and a beating heart printed through a bioprinter. So to say that there's a lot of promise in this area. For us in India, as a startup who's committed itself to applying innovation, we wanted to identify who our customer is and what does he actually want. So when we looked at the voice of a customer, one of the things we managed to relate to was a pregnant woman. In India, maternal mortality rate is higher than what it ought to be, and more so in South India. And in that area, the question which we identified as the voice of the client is, let me know early enough when there's an abnormality in the fetus so that my life is not threatened. Sadly, this isn't the case, especially when you go to tier 2 cities or tier 3 cities where diagnostic skills, radiology skills allow abnormalities to go undetected. So one of the things we have done here is called Protus Plus, is a complete 3D printed woman from the diaphragm down to the rectum with amniotic fluid, amniotic sac, everything, which can be used for training of doctors and radiologists. So that's one of the voices we listen to and connected to. A disabled person wants his self-confidence back. He wants to be able to live like a normal person and be independent at home or work. This is where our prosthetic arm came into picture, where we said we could definitely connect to that. Then when we looked at the defense applications, we had the opportunity to meet a commanding officer of a brigade, and he said, can I keep my communication lines alive beyond a border? When mobile technology doesn't help, is there a way of providing that? Can you provide me intel on the space beyond my border? So like this, we were able to identify snippets of requirements which have not been solved today, for which technology exists. So for us, it was a question of saying, how can we apply these essential technologies to fulfill that requirement? Ocular arrest. This is another superlative area which has remained, I would say, primordial for ages. Today, if someone wants an artificial eye or eye prosthesis, it's a very laborious process of taking a mold, of painting it, of matching it to the other. It's almost like you're sitting for a portrait with an artist. So they hand paint the ocular eye and then it's installed, and then the ocularist problem is, can I do it faster? Can it be more accurate? There are many times when after it's implanted, it doesn't fit. The volume does not match the volume of the ocular socket. So this is where again we think technology can make a big difference by making it faster and more accurate. Patient. Is everything about my procedure clear? How life-threatening are my tumors, as an example in this case? Do I need the procedure at all? Is the procedure safe for me? These are the questions which definitely technology can answer and give psychological comfort much before a procedure happens. To the doctor first, I can tell you of enough examples where doctors have said this is an inoperable procedure. We cannot operate on this patient. And the same surgeons have gone ahead and done a surgery after they were supported with better evidence on how they could actually do that surgery. So this is where our medical fraternity has to adopt aggressively technology which is reliable and consistent to make better surgical decisions and improve the patient care. Okay, so what are the innovations we are driving? I mentioned about Protus Plus. Protus Plus essentially lets radiologists and doctors and medical students train on scanning of fetus and the woman itself. With this scan, they are able to establish all the measurements they need to take, but what they normally miss is the abnormality. So we are in a position where we can print an abnormal fetus and see how many of the training doctors are able to catch the abnormality and get trained till they are able to catch that abnormality. So this is what will reduce the MMR rate by having surgeons in tier 2 towns who have less access to technology. In their place, they could get trained, identify the abnormalities and make sure that no woman goes back after a scan with an abnormality which is unknown. So that's one of the innovation. Then disabled person prosthesis, this is a patent which we acquired very early, and this is where we are again able to bring back grasping power to a person, because once a person whose upper limb is amputated, he gets back the power to grasp. He can almost do anything. So that's one innovation we have been able to drive. And let me get to this medical student. Worldwide, accreditation has become very critical. Medical colleges education is incomplete without a skills lab. Skills lab is a part of the accreditation process. Apart from the lectures, students need something they can touch and feel, operate on before they actually do it on a patient. Let's see how technology is changing this. Video, please.
My primary job is to safely take care of children who have major problems with their heart. One of my secondary jobs is to get the next generation ready to take care of children who have major problems with their heart. 3D models are all about trying to help them do that safely. learning on models instead of learning on patients. Here's an opportunity with 3D models to make the mistakes on the models.
A little about the innovations we are going forward with. Our first patent, like I said, was rearm. And the key elements of this design, which brought 4 very unique elements which were never done earlier, one was this prosthetic arm was pressure based. That means it could sense dynamic changes in the muscular pressure and use that as a trigger to trigger grasping or ungrasping. This is one innovation it brought in. Second is it's self-actuating. While the highest end of prosthetic arms could have electrodes here and sense what you want to do and move the arm, at the low end, we wanted a simple technology where the intent to do something results in changes in muscular pressure, and we capture that and use that to trigger grasping. So self-actuating was a key capability, because in the Indian context, if you provided a button, you provided threads to move, they don't last long enough. Greasy hands, dusty environment, and the heat will make it more maintenance prone, and that's another problem which is very hard to solve. So self-actuating was a very key capability for us. And then is extendable. Younger persons who have prosthetic arms, their limb grows, and after some time the same joint becomes a misjoint. So we designed something where there's a flexible soft element which can expand accommodating the growth of the limb and is modular enough to be replaced as well in time. So that's another innovation we brought in. So in the end, I would say the 2 key things which define this as a superlative product was self-actuating and providing grasping capability back to the effective user. The latest patent which we have filed is UAV for defense applications. Here, there was not a single feature which I could say was a defining feature. All of these requirements were required for our defense forces, every one of them. But there was no single product which could pull all of this together and say, here's your drone set, which of this do you want to try for the specific mission you have? So configurability, flexibility of payload, adjustments of power, hybrid power. These are the things which could bring in with our design, given the technology which we use, which help us provide a technology base which can drive more flexible operations for the defense forces. Low signature was also a requirement. That's where we're still working on, and that's also something which can enhance value. I'm going to run my last video again to tell you that it's very important to look for inspirations from all over the world, and then go to the customer, understand the voice of the customer, and see how you could apply technology to solve his problem, which is limiting his success. Video please.